if an autonomous AI accidentally drains your company's operating budget, the scariest part isn't actually the missing money.
Right. It's the explanation you get afterward.
Exactly. It's the beautifully written, highly confident paragraph it generates, telling you exactly why draining that account was, a brilliant strategic move to optimize your workflow.
Which is terrifying.
It really is.
Yeah.
Welcome to the deep dive. We are looking at a stack of sources today that gets right to the heart of what it means to give a machine real, irreversible power in the wild.
And it's a really fascinating cross-section of technical documents today. We're pulling from these architectural memos focused purely on AI agent security, and we're combining those with developer documentation for a Nostr to Bitcoin wallet called Ditto.
Which is a really interesting pairing.
Yeah, and alongside that, we have protocol specs for an Arc and Lightning payments integration called Second.
So our mission today, for you listening, is to answer one massive question. How do we safely grant AI agents real autonomy, like the ability to spend money, publish public content, mutate production code without completely losing control over what they actually do?
Because the current standard for agent design, it has a fatal flaw, and it's an order of operations bug.
Right. Okay, let's unpack this. Because the way agents work right now, it feels safe, but it's really not.
No, it's built for convenience, not security.
Right.
The standard operational loop is, an instruction comes in from you, the user.
Okay.
The agent assembles the context, the underlying model, chooses an action, a tool call happens like searching the web or drafting a response. The result comes back, and then finally the agent generates a summary explaining what it just did.
Which, that is perfectly fine if the agent is just summarizing a PDF or drafting a grocery list.
Sure, yeah, reversible tasks.
Right, if it messes up, you just hit delete. It's low risk.
Yeah.
But relying on that post-action summary for a high-risk task, it's like letting a house sitter completely remodel your kitchen while you're on vacation.
Oh, man.
And their only receipt is a beautifully written text message afterward claiming they, optimized your cooking momentum.
That's a great way to put it.
It's a lovely story, but it's not a control system. It's just damage control.
What's fascinating here is that we are constantly confusing fluency with evidence.
Tell me more about that.
Well, large language models are, by their very nature, prediction engines. They are designed to sound articulate. They don't have an internal objective state of truth about their own actions.
Right. They just predict the next best token.
Exactly. So if an agent executes an irreversible effect, say, sending an email to a client, or worse, editing a live database, it will use that exact same fluency to generate the post-action summary.
Even if it completely hallucinated the whole thing?
Yes. It can produce a deeply confident explanation, regardless of whether it perfectly followed your policy, half followed it, inherited stale data, or completely went off the rails.
So the operator reading that summary, you think you're in the loop, but you don't actually have control. You just have narration.
Narration.
The AI acted, and now it's telling you a bedtime story about what it thinks it did based on whatever context is left over.
And that narration creates a really dangerous false sense of security. A system where the agent acts first and explains second is a system where the boundaries are, they're entirely theoretical.
So how do we fix it?
What the architectural memos argue is that we have to fundamentally invert this loop. We have to force the system to commit to its exact intentions before any irreversible action is allowed to fire.
Okay, and the memos refer to this as receipts before effects, right?
Yes, or borrowing from database architecture, a write-ahead intent log.
Which databases have been using for a long time.
Decades, yeah. If a database is updating financial records, the system might crash halfway through. To prevent data corruption, the database writes its exact intended change to a log before it actually touches the core data.
So there's a record of what it was trying to do.
Right. If a crash happens, the system can look at the log and either finish the job safely or roll it all the way back. Agent systems require this exact same discipline, but for authorization.
Wait, I need to push back on this a little bit.
Sure.
Requiring an AI to write out a highly detailed formal receipt for an action that hasn't even happened yet, doesn't that completely grind the AI's speed to an absolute halt? The whole point of an autonomous agent is speed and efficiency.
That sounds like a bottleneck, I know.
If it had to pause and do paperwork before every API call, we've kind of ruined the product, haven't we?
It feels like that until you realize this isn't a diary entry for a human to sit down and read. It's a machine-readable control surface. We have to separate what the memos call the reasoning path from the receipt path. When the AI decides to act, It generates this intent log rapidly as a structured data object.
So it's just firing off code.
Exactly. But here is the critical mechanism. You cannot rely on the same AI that took the action to objectively verify if the action was authorized.
Because asking the AI to verify its own homework just turns it back into a narrator again.
Precisely. The verification has to happen outside the primary LLM's reasoning engine. The intent log is evaluated by a separate deterministic system.
Like standard code.
Standard code, or a highly sandboxed read-only verifier. If the intent log violates policy, the deterministic system kills the action before the tool is ever called.
Right. Because speed doesn't matter if the machine is driving off a cliff.
Exactly. Speed is irrelevant if it's doing the wrong thing.
So let's break down what actually goes into this intent log, because the sources outline 8 essential fields for a minimum useful log. And honestly, thinking about how many agents operate without this right now is terrifying.
It's a lot of them.
Let's say I have an agent tasked with managing my cloud infrastructure.
Okay, good example. So the first field in the log is actor identity. Is this action being triggered by the primary agent, maybe a temporary subsession, or a human overriding the system?
We need to know who is driving.
Right. The second field is authority. Which specific permission, API key, or wallet is actually being used to do this?
Okay, third is the action class. This basically categorizes the risk, right?
Yes.
Like, is the agent just reading data? Is it writing new data, spending funds, mutating a live environment, or maybe delegating a task? Reading a log file is a very different risk class than deploying new code.
Radically different. Which leads to the fourth field, the target. What specific surface is being touched? Is it a local test sandbox, or is it the live customer production database?
You definitely want to know that before it fires.
For sure. Fifth is the expected effect. Before the action happens, the agent has to define what the exact state change should look like if this succeeds.
Okay, and sixth is the boundary. This is the leash. It defines the maximum budget allowed, strict rate limits, or the specific file scope the agent cannot leave.
Right. Seventh is expiry and revocation. When does the authority naturally time out? And more importantly, what is the specific kill switch the human operator can hit to terminate the path?
You always need a kill switch.
Always. And the eighth field is really where the magic happens, the reconciliation rule.
Okay, how does that work?
This defines exactly how the separate deterministic system will verify what actually happened against what was intended in field 5.
Give me an example with that cloud infrastructure agent.
Sure. So the intent log states the expected effect is to reboot server A. The action fires. The reconciliation rule dictates that the system must check the cloud provider's API for the status of server A.
Okay.
If the API returns that server A is rebooting, it's a match. The state reconciles. But if the API shows that server A, B, and C were all deleted, right, the actual effect didn't match the intent log. It triggers a hard failed state, instantly locking the agent out of further actions.
Which means that beautiful, human-readable summary you get at the end of the day, that summary is derived purely from the reconciled receipt path.
Exactly.
It's built on hard cryptographic or API evidence, not on the AI's hallucinated memory of what it meant to do.
It transforms the summary from a piece of creative writing into an actual audit report.
Here's where it gets really interesting, though, because a developer might look at all this intent log infrastructure and think, well, I can avoid all this complexity. I'll just give my AI a static allow list of safe tools.
The classic approach.
Right. Like, you are an agent, you can only use the weather API and the read file tool. But the architecture memos tear that entire philosophy apart.
They do, because static allow lists are fundamentally flawed. They assume a tool's risk profile never changes.
But risk changes with context.
Entirely. Take that safe read file tool you mentioned. If the agent uses it to read a public markdown template for a blog post, it's harmless. But if the agent is tricked into using that exact same tool to read an exported list of encrypted customer passwords or an internal financial ledger,
then that safe tool just became a massive security breach.
Exactly.
Using static allow lists is like giving someone a VIP all-access pass to a concert venue. Sure, you trust them to get free drinks in the VIP lounge, but technically, that physical badge also lets them walk right backstage and unplug the main speaker cables during the headline set.
That's exactly it. The badge itself is dumb.
Right. The badge doesn't know where the person is or what they are doing.
If we connect this to the bigger picture, when developers rely on static permissions, they inevitably end up writing postmortem incident reports that say, well, technically the agent had access.
Which is the worst thing to have to write.
It's a total failure of imagination regarding context. Even a benign tool can become a weapon. Calling a cheap translation API once to translate an email is totally fine. But if the agent gets confused in a loop and calls that same API 2,000 times a second...
It's a denial of service attack on your own budget.
Yes. And delegation is another huge blind spot here.
Oh, right. When agents spawn other agents.
Having an AI spin up a child agent to handle a subtask feels like the holy grail of automation. But if an agent tasked with researching competitors spawns a child agent, and that child automatically inherits the parent's paid API credentials and full memory access...
Without a fresh set of boundaries.
Right, without boundaries, you've just created an autonomous, unchecked spender.
So what's the alternative to the static list?
The memos propose a shift from static tools to dynamic capability envelopes.
Dynamic capability envelopes, okay.
It's a highly specific permission slip. It shrinks, it expires, or it demands stronger human approval based entirely on the context.
You mean example?
If the task requires spending $5, the capability envelope allows it. If the agent suddenly tries to spend $500, the envelope shrinks, blocks the tool call, and flags the operator.
So you aren't granting access to a tool, you are granting a specific bounded capability that exists only to fulfill a single intent log. So if we establish this ironclad control, plain right ahead intent logs, evaluated by deterministic rules operating inside dynamic capability envelopes, how does the AI actually execute an action out in the physical world?
That's the next big hurdle.
Because traditional banking and payment gateways will instantly flag and block an autonomous script trying to ping a corporate credit card thousands of times.
Oh, absolutely. They'll lock it down in seconds.
So how do we give these agents a verifiable programmatic wallet they can actually use?
This is why the architectural memos pivot to decentralized protocols. They look specifically at Bitcoin, Arc, and Nostra as design references. But before we get into the mechanics, the data scans in our sources issue a massive warning about hype.
Yeah, we see the headlines all the time. AI agents are going to use the Lightning Network to trade with each other and run companies while we sleep.
Right. The reality is much quieter. A recent scan of developer communities shows very thin evidence of any massive breakout where AI agents are natively using Lightning at scale.
So it's not a magic bullet yet.
Not at all. Developers aren't looking at these protocols as magic dust to sprinkle on their AI startups. They're looking at them as architectural design references for how to build verifiable, cryptography-based systems that don't rely on centralized permission gatekeepers.
Which brings us to Ditto.
Yes.
Ditto is a Nostra to Bitcoin wallet, and the developer documentation here is wild because it shows how seamlessly identity and finance can merge when they share the same cryptographic roots.
It's a really elegant piece of engineering. Both the Nostra social protocol and Bitcoin's Taproot upgrade utilize the SEC256K1 curve.
Okay, wait.
They both rely on Schnorr signatures, and they both use 32-byte X-only public keys.
Hold on, I need to stop you there.
Yeah.
You just threw a lot of heavy cryptography at me. Curve what, sure who what. What does SEC256K1 actually mean for an AI agent trying to autonomously buy server space?
Fair enough. Let me break that down. Think of cryptography like a spoken language. Traditional web systems speak dozens of different incompatible languages.
Like English, Spanish, French.
Exactly. Your bank speaks one language, your social media profile speaks another, your email speaks a third. To connect them, you need massive databases acting as translators in the middle, and those translators are slow and require permission.
Makes sense.
What SECP256K1 and Schnorr signatures mean is that Nostr, the social identity layer, and Bitcoin, the financial layer, speak the exact same mathematical language natively.
So there's no translation needed at all?
None. A Nostr public profile key, the thing that identifies you as a unique user, is byte-for-byte identical to a Bitcoin Taproot wallet address.
Wow.
There is no hashing, no complex derivation path. Your social identity literally is your financial vault.
For an AI agent, this is massive. It means the agent doesn't need to manage a separate identity module and a separate payment API. Its identity key intrinsically holds bare assets.
Exactly. And the Ditto documentation also details NIP73 for external content identifiers.
What does that do?
This allows users or agents to leave Nostr comments and reactions directly on Bitcoin transactions. They also utilize kind 8333 on-chain zaps.
Okay, kind 8333. I saw that in the docs.
Yeah, it's an event type on Nostr. When a Bitcoin transaction is broadcast to that shared Taproot address we just talked about, a kind 8333 event is automatically published on the Nostr network.
So it acts as an immutable public receipt.
Precisely. It attributes an on-chain payment directly to a specific Nostr identity. It's cryptographic proof of action.
Then we have Second, which handles the Arc and Lightning side of the equation. Second's Arc implementation introduces something called virtual UTXOs or VTXOs. Why do we need virtual versions of Bitcoin transactions, and why do they live off-chain?
Well, on-chain Bitcoin transactions are incredibly secure, but they can be slow and carry fees depending on network congestion.
Right.
If an AI agent needs to make thousands of micropayments a minute to access data streams, waiting 10 minutes for a block confirmation is a non-starter.
Yeah, that kills the speed.
Arc allows users to connect to a server and transact these virtual UTXOs completely off-chain. It provides instant, incredibly cheap settlement.
Is it safe if it's off-chain?
Yes, because crucially, you maintain the cryptographic assurance that you can pull those funds back onto the main Bitcoin blockchain at any time through round-based anchors.
And Second features an Arc to Lightning gateway. This blew my mind when I read it.
It's very cool.
It lets users or autonomous agents pay Lightning invoices instantly, directly from their Arc balance. It happens atomically. The agent never has to manage Lightning channels and never has to worry about inbound liquidity or running a routing node.
You combine these pieces and you get a really powerful toolkit. Ditto shows how to perfectly merge identity and bearer assets using shared math. Second and Arc show how to achieve instant off-chain bearer settlement without sacrificing self-custody or verifiable history.
It is the perfect playground for autonomous agents.
It is.
So what does this all mean? Wrapping this all up with Ditto merging social identity and wallets and Arc making Lightning payments instant? Are we just plugging these into AI agents and letting them trade with each other?
This raises an important question, and it brings us back to a massive flashing warning sign.
The reality check.
The reality check, yes. These protocols are incredibly powerful. Bitcoin gives us final settlement, Lightning gives us fast bearer payments, and Nostr gives us portable signed events. But none of these technologies automatically solve the AI authorization problem we started with.
Because proving a transaction settled is not the same thing as proving the AI had the budget authority to make it.
Exactly. A Lightning payment routing successfully proves that the settlement happened. The cryptography holds up, but it does absolutely nothing to prove that the AI agent had the authority from its human operator to drain that wallet.
Wow, yeah.
An agent could seamlessly, instantly drain your Lightning balance using your perfectly valid Nostr identity, all because it hallucinated a reason to buy 5,000 digital stickers instead of paying for your server hosting.
So the settlement was mechanically perfect, but the autonomy was a total disaster.
Yes. Which is why the decentralized protocols don't replace the write-ahead intent log, they require it.
Decentralized networks give us an environment that verifies state instead of trusting a narrator. They provide append-only histories and cryptographically signed receipts.
But the missing control layer, the pre-action intent, the scoped authority, the dynamic capability envelope, that still has to be built by the developer.
It all boils down to a framework for safe execution. The sources define 5 pillars that must be present for any autonomous action to be considered safe.
Think of it as a life cycle. The first pillar is committed.
Meaning the intent log existed and was recorded before the actual effect took place.
Yes. The second pillar is bounded. The agent didn't just have a blank check. Its authority was strictly scoped by its identity, a specific budget, a specific target, and a hard expiration time.
Okay, the third is executed. This means the actual tool call like the API ping or the Lightning payment happened entirely within that shrinking dynamic capability envelope we talked about.
Exactly. The fourth is reconciled. The system systematically verified that the actual effect on the world, like the server actually rebooting or the invoice actually settling, perfectly matched the intended effect defined in the log.
And finally, the fifth pillar is stoppable.
Which means throughout that entire life cycle, the human operator had a clear, functional, mechanical path to revoke the agent's authority before it spiraled into a crisis.
If you are building an agent system and you don't have those 5 pillars, committed, bounded, executed, reconciled, and stoppable, you don't really have an autonomous agent.
No, you just have a very fast, very fluent liability waiting to happen. But if those pillars are in place, then you can take that reconciled data, feed it back to the language model, and let it write you that beautiful, human-readable summary.
Because then the summary is the final victory lap, not the starting line.
Receipts before effects.
It completely inverts how we approach AI acting in the physical and digital world. As we close out this deep dive, we want to leave you with something to mull over.
Something to apply to your own workflows.
Exactly. Would you let an AI agent spend your money, publish in your name, or mutate your data if the only receipt you received was written after the fact? Look closely at your own stack. What is the first irreversible action in your daily workflow that desperately needs a write-ahead intent log right now?